universal statement, and he
Right.
kind of just refused to respond to that. Honestly, he didn't ever address it.
He's a troll. I blocked him after. I think he was the first person I blocked from Standing for Truth because sort of I said something and then we went on to Amy's after show and he completely lied about what I said, just blatantly
Yeah,
lied, and then
he
sort of
did the
laughed about
same
it.
to me tonight.
Yeah, he has for somebody that believes he shouldn't bear false witness. He does an awful lot of bearing false witness. So I'm very familiar with the guy that you're
He
talking
was
about.
trying to make the claim that I somehow claimed that I can explain every aspect of the universe independent of God, and I
Right,
have all the answers, and if I don't, then obviously I cannot be, obviously my worldview is fraudulent if I don't have literally every
right.
answer to everything.
Right. So that's where, he'll outright lie about it and sort of, it's not even at the point of misrepresentation, like even the, slight misrepresentation. He will flat out lie about what you've said and what you've claimed. So just block him. He's not worth your time. He knows that he's lying because he laughs about it afterwards. He's really not worth your time,
Well, I
Grayson,
mean,
honestly, man.
people seem to the most watched long format debate on my entire channel was with Redefined Living. So I don't know if people like and enjoy those debates. I really have no idea. It wasn't particularly enjoyable to me to have these
Yeah. Fair
pedantic
enough.
little arguments, but
I don't know.
speaking of,
I don't do a
that's not
lot
really
of
fair for John Doe, but I wanted to read out his question because I've never heard
sure, sure.
anybody ask this before. He says, "Why don't evolutionists believe that deities can exist? You don't think that Q could have evolved? It makes no sense to me. If you believe anything is possible, you vehemently call yourselves atheists." Anyone want to take that? Because I've
Oh
never heard
yeah,
of anyone saying, "Couldn't
yeah.
God have evolved?"
So, well, yeah, that's the whole point. It depends what you're defining as God. Sure, a God could evolve. There's no reason to think a God evolved. But the problem here, John Doe, your main problem is saying why don't evolutionists believe that deities exist? But um, there are theists that believe in evolution, right? So there's a ton of people, even working within evolutionary science, that believe in a God. They are religious. They are theists. They are Christians and Catholics and Islamic people and all kinds of people. So some of them do think that deities exist, not just can exist, but do in fact exist. You're sort of conflating this idea that evolution has somehow been put in there by atheists, which are a tiny minority of the population. That's not the case. It's that is the scientific consensus among everybody, including religious people. This is the thing you've got to understand. It's not an atheistic thing. Evolution is just a scientific thing. And I'm really sorry, but there's tons of theists, people that believe in God, that also know evolution is a fact because we observe it and there's tons of evidence for it. I'm really
That's a
sorry,
great
but
point.
your question is kind of malformed. Um, it, to believe anything is possible, right? So yeah, so when you believe something, um, you have to have sort of a positive leaning towards it. So um, we don't believe anything is possible. There's some things that are logically impossible, like a married bachelor and things like that. But usually the atheist will say, hey, there's nothing logically impossible about a God. There's nothing inherently flawed about the idea as far as logic is concerned. However, there's no evidence to believe in a God, and there's a lot of evidence, like the problem of evil, to sort of make it seem like there isn't a God. So that's why we believe there's no God or do not believe there's a God, is because the atheist doesn't have that evidence to show that it is real. We don't just believe anything is possible, and we don't just believe anything at all. It's just what do we have evidence for? And I'm sorry, but a God isn't it. Anyway, I've been talking too much. You go, Grayson.
Yeah, so I'll agree with you there, Mark. 100%, or maybe I should say 99.99999% to
Yeah,
avoid any
yeah,
universals. But yeah, no, I pretty much agree with you. I mean, I've never said that God is impossible. There's lots of things that are logically possible. I've said before, I think that a leprechaun could have farted out the universe. Sure, it's possible. Why not? I don't have evidence to support that. But we have another comment here from John who says that he will give me a cookie if next time I say to not a Dr. Kent Bovind that nobody has ever seen a god produce a non-god. John, you will owe me a cookie, good sir.
That's a really good point. It's something I've made before, but that's really good wording of it to sort of parody what Kent says. Like we've never seen a god create anything either. You know, he sort of says, "Hey, we've never seen a bacteria turn into an elephant." Well, we've never seen a god, create something from nothing either, or humans from dust either. But you believe that. But I love that we've never seen a god create a non-god. That's beautiful, John. I love it. John's awesome. He's
Yeah, it'll be
absolutely
interesting to
awesome.
see
Yeah.
how he answers that.
Yeah.
So here's an interesting question from Lorraine. What's the oldest evidence of a supernatural belief? Is it a 50,000-year-old burial in Israel? And even that is an assumption. So that's an interesting question. I would think that beliefs would predate humanity, would be my intuition about it. I mean, we've seen chimpanzees d- demonstrate some level of supernatural belief before.
Right.
So I would see that it would probably predate humanity. Could go back to Australopithecus, could go back even further. Tough to say, but I don't know the archaeological evidence for the most definitive, um, evidence of a supernatural belief being demonstrated in the archaeological record.
Yeah, I don't know what it would be. I know, being Australian, that the Australian Aboriginals, the native people to Australia, they have sort of beliefs that go back a very long way, at least 45,000 years. The Dreamtime and the Rainbow Serpent, which is their sort of origin myth kind of thing. But I'm not sure about what the oldest in the world is. But yeah, I would agree with Grayson. They were probably, if not around before humans, definitely before Homo sapiens. So Homo habilis and things like that. Absolutely.
So this is an interesting, and I pretty much agree with Rocius here that God is 99.9% impossible because we have to make room for the myriad of other improbable ideas. So I think
Yeah,
that pretty succinctly summarizes what we were talking about earlier.
sure. Yeah, if you don't
Taylor
want to have
K is in the building.
bias. Yeah. Hi, Taylor.
Hey, Taylor. Okay, so rational empiricist. Sorry, I hope you're not feeling too ignored. I added you onto the stream a little while ago, but I'll just formally introduce you here. Um, I did.
Oh,
I really enjoyed your contribution in that open mic with Kent on Praise's channel. I
I,
uploaded it on.
I'm flattered that thank you for your comments, and I appreciate you uploading that into a more uh succinct, watchable form than
Yeah, I really
the whole
enjoyed it,
stream.
especially. I don't know if you saw at the very end there, but just when Mark, to give you some background here. Um, A rational empiricist was literally doing exactly what Kent has always asked. He stuck to one topic, a very, very specific topic about the Aeolian formation of sandstone. And
Right.
Kent continued to try over and over again to change the topic, saying,
Yep.
"Oh, do you believe in a dot of nothing exploding?" And it was just comical at how, I really have to
Mm.
applaud a rational empiricist for not uh, taking the bait and holding his feet to the fire and staying on topic because honestly, I
Thanks.
probably would have just gone with the punches and I would have
Oh,
started
well
talking
done.
about the dot of nothing.
Did you
Yeah,
did you clip it? I mean, I'll watch it on your channel, Grayson, if it's
Yes,
there.
it's
I don't
on my
usually.
channel
yeah, it
right
was on
now.
his.
It's, like I uploaded a video today, but it's my most recent video before that.
Right.
I have, like,
No,
my
I will
little
watch it. Yeah.
interaction with Kent at first, and then I have a
Mm.
rational empiricist at the end, but I enjoyed I enjoyed a rational empiricist, part portion of the debate actually more than I enjoyed my own. I thought he did a great
Well,
job.
I think you did pretty good, Grayson. Yeah, I think Kent was um maybe a little more. What's a good way of putting it? He was more used to. Oh, hey, Bree.
Hey,
He was more
Bree.
used to kind of what you were saying. So what am I trying to say?
Well, yeah, he had canned
Yeah,
responses, but even his canned
mm,
responses were
yeah.
absolutely loony. Mark or Bree, I
His
don't know if you
idea about
guys.
like the whole idea of the Earth like sloshing around like a
Yeah,
tide.
He
It's
needs
I'll
to
hard
just
check
to
the
throw it out
imagine.
expiration dates on some of those cans, y'all.
Yeah.
there. So
I
Mark
think
and
they're well
Bree.
past you. Yeah.
Yeah, so in this, Kent was actually trying to say that the fossil footprints that we find for terrestrial
Yeah,
animals in the Grand Canyon were formed during the flood because apparently a patch of dry land was
yeah,
continuously
patches of
shifting
dry
around.
land
And
existed.
so the flood would deposit some layers and then animals would walk on top of it and then the flood would come back around and deposit more layers.
Ooh,
This is
it's actually
this is just
not just
information.
that because there's newer layers on top above that that have burrows in them. So
Right.
it's
Yes.
it's the
Right.
animals walked on that, the flood flush washed back, then some burrowing animals came along and
They had
burrowed
time to
into
make
it.
burrows.
And then
And
in between
really
what
interestingly, I
How
really
did
did
they
not expect this.
survive?
Yeah, I really did not expect this, but I actually even corrected Kent on the Bible in that exchange. I'm not a Bible expert. I don't know anything about the Bible, but I couldn't believe it when he said that um, Noah didn't release any birds from the ark for a full year. And I said,
What?
no,
no,
he did it multiple
No.
times continuously, starting at like 40 days. And I
Yeah,
couldn't
it
believe,
was
like,
a raven, then a dove.
yeah,
I think yeah,
a
they were
raven,
different
yes.
birds as well. Yeah.
And I just
that's
couldn't
part of
believe.
my that's part of my argument against kinds because if our most people would take the argument back to the family level, but then you're talking about these different birds that were already distinct by this time that are all in like the group with the passerines, right? This kind of neo aves group that or avis group that
Hmm.
has like modern features, and there were two of them. There were at least two of them. So how many birds were there exactly? Anyway, I'm throwing
Yes,
off the
Lorraine,
subject.
just to answer the question in the comments here, it is the
Mhm.
video titled "An Impromptu Debate." So that's the
Yeah.
in the title of the video.
Actually, I've used the
So
same tactic as rational empiricist, sort of against Kent with his evolution thing. I just stick to ERVs because he doesn't have anything to rebut it. He just
He's
basically
not used
says,
to it. No.
well, he just basically says we don't know it, and then he consults sort of Donnie's work, which Donnie's entire
Right.
argument against ERVs is, oh, they're beneficial, and it's like, yeah, they're co-opted. We know this is the case. Like that doesn't refute,
Yeah.
and it doesn't
Lots of people
explain.
have tackled his whole ERV stuff. To be
Yeah,
honest.
so this doesn't explain how the actual viral DNA got there. And I know I sent that question into Kent because I know he hates it, and he had the slides up before he was even asked the question. So either A, Donnie's
Right.
feeding him these questions, which maybe is true, maybe not, or B, he's got people watching for the question to send him, hey, it's going to be about this, and he gets the slides up in preparation, which is
It
probably more
is kind of
likely.
heartwarming in his own heartwarming to me, and in his own special way, his own twisted way, Kent is actually trying to learn something in
okay,
terms of
I'm
what
gonna
Donnie
try
is
something.
telling him.
I'm gonna try something really quick, and I'm gonna try to explain ERVs very quickly and
Mm.
simply. So ERVs are endogenous retroviruses. Okay, big word, doesn't matter. ERVs is fine. They're a portion of the DNA that has viral like characteristics. There are portions of the ERV which are clearly viral genome elements. We know this because we can see viruses infect organisms today, and we see that they are inserting ERV elements into the host organism's genome. So, by comparing which animals have what ERVs in common, that reconstructs the phylogenetic tree that we would expect if
Right.
evolution were
Yeah.
true. And this is different than just saying they're genetic similarities because of common design, because the vast majority of ERVs don't exhibit any kind of function that we can see, or their function is not clearly related to their ERV elements. So
I do have a
it's like a genetic
PowerPoint.
similarity argument, but
I do have a
in not using
PowerPoint on it
genes.
if you do need me to go through it on ERVs.
Sure, yeah, be my guest.
Well, it's up to you. I mean, I don't want to. I just found the PowerPoint
I
presentation,
was
so
just trying to answer very quickly and succinctly. So if you had a
okay.
maybe something that you wanted to add or something you thought I left out,
Um. So yeah, I'll just do the PowerPoint real quickly. Go through it. Probably better
sure.
than the best.
I will say, Grayson, it does appear you've attracted some creationist faces in the side chat now.
Really, I wish that they would join the actual discussion here, but
By the way, I hope my is my audio coming in okay?
yes, it is.
haven't used StreamYard in a while.
So, Taylor, just to clarify, like 99% of ERVs exhibit no known function. Donnie likes to point out the 0.01% of ERVs which have developed functions or which were already functional when they were first infected. So,
I
it's
mean, there are
really a
also
question about
ERVs
fractions.
that are detrimental
Yes.
to
So it's a
health of
Yes.
question
the
about
organism.
fractions. When Donnie says
Yeah.
that ERVs are functional, it's very misleading because he's talking about 0.01% of ERVs and he's trying to act like he's talking about all ERVs. So that's why it's very misleading. You have to be aware of the fraction of what amount of ERVs are functional compared to the total.
Yeah,
I will
I'm
also just
sharing
say,
my
at least in
screen.
my translation of the Bible, Noah releases the raven after 40 days.
Yes. I'm sharing my
Um,
screen. I'm not sure if that's coming up or not. It's been
oh, I see it right here. Sorry
yeah,
about that,
sorry,
Mark.
sorry, sorry. Yeah, yeah, no worries, no worries. So basically, this is the process that you've got viral. This virus's um, RNA, and it inserts itself into the human genome. So this viral RNA gets inserted. So we know from this sequence here that there's part of our DNA that is viral, and mostly from these long terminal repeats on either side, we can tell that that's a viral element. As the virus gets infected and passed down, it endogenizes when it basically becomes standard, when it becomes a normal part of our DNA. And all of this is natural, and it's actually can be a really good thing when it does get passed down, because what can happen is the viral sequence can get mutated. Now, mutation is when a family has a child and some of their DNA is randomly switched or randomly different kind of thing. But that can happen to the DNA from the virus that's been inserted into humans. So it can change, and occasionally it changes so it's a better version. It's helpful in some way. So that's what we call co-option. So these usually a retrovirus is really bad, but because it can mutate into something that actually helps us. Um, and all of this a bit complicated, so I'll leave it there. But I just wanted to explain how, like, where it came from. It came from these viruses, and even though viruses are usually bad, if it if it mutates into something good, we keep it. We basically will do better, and it will get passed down again and again and again and again.
Sometimes they can bring DNA from different organisms to help a different when you get an ERV, it can bring in. I know that they've white flies have had a plant gene inserted into them to make them
Oh,
immune
really? Wow.
to the toxins in the plant, and also helps them to produce the toxins themselves to keep their predators away. So they have plant genes inserted into them. Really cool
Hmm.
stuff. ERVs can do amazing
So
functions.
how we know how this supports evolution is that we find that these exact viral sequences in different animals, like for instance, like you'll find a certain ERV sequence in both us and cows, for instance. Now, it's in exactly the same place and is exactly the same viral sequence. So we know that the chances of that happening independently over all these animals is so large. It's so improbable. It's so unlikely that the same virus attacked the same animals at exactly the same place in their DNA is so improbable. It just couldn't happen. The other explanation is that before, say, cows and humans split off, they were infected way back then, and something happened to mutate that ERV, and it became um, beneficial. And because it was beneficial and because it helped, we both the cow and the human's ancestor kept that. They split off from one another, but it kept the same viral element in both the cow and the human. And then that's how we got it. And that is a way better explanation than all of these viruses just happen to infect at the same place in every single animal. Um,
Yes.
yeah, so that's why it's really good. It's probably the strongest evidence for common ancestry.
Yeah, so just to drive that point home, it's the patterns that we see in the sequence and the location of these ERVs throughout the
Right.
genomes of all species on Earth. And well, all species that can get infected by an ERV. But it's the patterns that we see that reproduce the phylogenetic patterns that we would expect of evolution. That is the reason why ERVs are such strong evidence for evolution. The reason why they are not strong evidence for common design is because there's not function in the vast majority of them. And to say that all ERVs are functional, like Donnie or like Kent will have to say, is a completely faith-based assertion. They just have to believe that all ERVs are functional because that's what their worldview says if it's common design. If
Well, even if they are all functional, it's kind of beside the point because you don't have to have them in the same genetic location for them to be functional or have the same sequence. That's not how genetics works
Right. And
usually.
there's another
yeah,
reason why it's not designed, and that's because of the long terminal repeats on either end. So what
Right. Yeah, I was
happens?
about to mention that. Yeah.
Sorry, go ahead, rational empiricist. I don't want
Oh
to step on you.
no, go ahead. My
Well,
take on it will probably be different than
when
yours.
the virus, when any retrovirus, it doesn't matter whether it's been endogenized or put into the population or not. Any retrovirus, what it does is it makes a cut in the DNA of its host with an enzyme called integrase. Now, this integrase, when it does make the cut, it makes a repeat of the DNA around it. So it basically causes a repeat to happen. So it duplicates it. Now, when the virus transmits itself, so when the virus produces more of itself, it doesn't include the long terminal repeat. It doesn't include this repeat of the DNA sequence. So the only way it can get there is when integrase makes a cut in that DNA. And so why would a designer design a property of DNA to make it look like integrase has made a cut there without it actually happening? You would actually have to argue that um, the god designed this DNA sequence with the elements of a virus and then also designed the outside of the viral element with the long terminal repeats simulating that integrase made a cut in it, which seems incredibly unlikely.
yeah, and speaking to Taylor's point here about is it possible if all of these ERVs do have a function and we just don't know what they are? I'm going to ignore the point about vestigial organs for now. But I would just say that some of these ERV elements do have like recognizable like genes within them, but they're degraded to the point where they're no longer functional. They're broken. And the key here is that they're broken in the same way among evolutionary clades.
Right.
So,
But they're not always completely broken, no. I mean, let's not oversell it, right? There's the you can have it,
No, they're not.
it's still functioning, because like Mark was saying, it'll duplicate that sequence that it's cut out. So it'll still try to replicate the function through anyways, I'm sorry. I didn't mean to barge in there.
Some elements of it can be functional, but I
Yeah.
don't think we've ever found a complete ERV that has the same original function.
yeah, like even
So
in the case
it's
of
broken
syncytin,
in that
which
sense.
even in the case of syncytin, which is a functional gene within an ERV element, the
Mhm.
actual aspects of the ERV element, like the long terminal repeats, are not necessary for its function as a syncytin protein.
Right.
Right.
Okay.
Um,
Yeah, I'm not sure. I don't know. So
But yeah,
I'm gonna
there
believe you
it is.
guys.
and I'll just address this point really quick. Big Bad Mana is saying that the functions are irrelevant, the insertion locations are the key. And I'll just say that according to many creationists, the insertion locations are a part of the function. They will make the claim that these ERVs have to be in these locations that they are for some kind of functional purpose.
Yeah.
And that is what they have faith in.
Why are there so many ERVs that don't have any function at all, though, that are just like dead? Like this,
Well,
it's a
again, they
dead end.
have faith that they do have a function and we just don't know it. It's a
Science
faith-based belief.
will eventually discover it. All the
Yeah,
functions.
so they allude a lot to the whole idea of junk DNA, which is sort of a lot of DNA that we thought had no purpose. We found out some of them did. I'm not going to say that maybe there's some we don't know the function, and maybe it does have a function. That's possible, but there are some cases of ERVs where we know they definitively have no function whatsoever. To the
I
point I
had really
believe.
never heard the term junk DNA before I started interacting with intelligent
Yeah.
design
I have,
people.
yeah, I have. Yeah, I'd heard that term thrown around a lot
I
before
think
I
it at
even got
least
into
became
this.
more on the stage, so to speak, after creationists started
Oh,
butchering
sure,
it.
yeah, yeah. It's kind of, yeah, it's kind of before we really knew that much about epigenetics kind of thing. We didn't think they sort of had a function, and the function, the gene is expressed in terms of the environment around them kind of thing. So they do have functionality, but that's just because the whole idea that there is X amount of junk DNA doesn't mean the entire thing of there is DNA in your system which doesn't need to be there. You can literally replace one genome with another one, or one sequence with another one, and nothing will change. Like it just does nothing. That is a thing. So
So I'll just point out to that something that Standing for Truth has actually told me in response to that is that he'll just say, "Oh, but the circumstances from which we would see a functional difference don't come about in the laboratory setup." He has faith that there's some kind of circumstance that could come about where then we would see the functional difference,
So
but
it's just
it's
that
all faith.
we
Mm,
haven't
And
had
just really quick,
the right environmental pressure to act on it to
sounds
cause
like
it
some
yes.
to
special
cause
So
it.
he
pleading to
has a
me.
lot of faith in that. But just really quick, I just want to welcome Leo Filius in the chat and just want to let him know that so
they
Leo and
are
I will be doing a debate on Modern Day Debate on the Big Bang against
nice.
Sal and Rebecca.
Oh,
And
that's right. You've got that with Sal coming up. What does Sal
yes,
know
and so
about
a rational empiricist
cosmology?
actually, yeah, a rational empiricist actually mentioned me and said that he has had a conversation with Sal on the Big Bang, and that
Mm,
he wanted to discuss some of his takeaways from that interaction. So Leo, if you wanted to jump in, it could be valuable for
yeah.
us, but I'll be sure to hold down the fort if you
Yeah.
can't.
Well, what I say, Leo probably already knows. I just want to make sure both parties are on the
Oh,
same
you just
page.
want to
So
make sure I know it.
yeah.
Gotcha.
We're
And
colluding.
if you want to subscribe to Leo, he was just earlier today. He was doing a breakdown of some
Oh yeah, he was
physics
doing
and
something earlier.
philosophy stuff. Yeah, it was
Yeah.
pretty good stuff. So had William Lane Craig and stuff on it. So yeah, if you're not subscribed to Leo, go check him out. He's
Yeah.
Mm.
Warm
And I also want
always
to
welcome
doing
to
some good
plug
Leo out
content.
here.
I also want to plug Ian Chen is having a round 2 with Kent, so in the first
Oh
week of
no.
April. So everyone have that on your radar as well.
Rock hard Kent.
Yeah, rock hard Kent, which
Well,
nobody wants to think about.
I
Well,
don't want to debate Kent due to the current stuff that he's doing, but I must admit I
Yeah.
challenged him today because he went on Whack an Atheist and told the world, and Emma Thorne particularly, that he would debate them on whether DAL is a cult or not. So that is too good an opportunity for me to pass up. So I wrote in a super chat, and gave Donnie money to say, hey, you said you would debate people on whether DAL is a cult. Let's debate that. Because I think that would be fascinating what you could bring up in support of DAL being a cult. Even if it's not conclusive, it certainly is quite embarrassing for Kent. But Johnny was, of course, like, "Oh, I can't ask that question on chat." It's like, come on, dude. Like, he's going around challenging people to debate him on cults and DAL. Can
But I
we?
think
You
Can
could
we?
someone
run DAL
commented
against
about
the bite model. Has anybody done that?
No, um, but
Seems like something that should be done. Yeah.
Do you want to elaborate on what the bite model is?
Yeah,
it's
it's a
like
model
a
that they use to
yes.
uh to predict or not, yeah, to predict whether a group is a cult and whether they're going to likely to engage in
hmm,
uh the dangerous cult activity or to progress into dangerous cult activity.
Well,
So
it's just
it's called
authoritarianism,
bite.
isn't it?
It's behavioral control. What does it stand
Information
for? Behavior,
control,
information control,
thought
thought
control,
control,
and
and
emotional control.
emotional control. Yeah,
hmm.
those are the steps that they take to uh, take control over their members. So we can look at the way that things are handled at DAL and put it under that scrutiny.
Yeah, I mean, look, the thought control is definitely something that Kent's going to have a problem with. Require members to internalize the group's doctrine as truth,
Mm-hmm.
adopting the group's map of reality as reality, instill black and white thinking, decide between good versus evil, organize people into us versus them, i.e., insiders versus outsiders. You're not doing well, Kent. But yeah, but
Mm.
what I want to know is why does he go on and sort of say, "Hey, I'll debate this topic," and I don't feel like he's got any interest in debating that. Like he won't
Hmm.
take it up.
Well, you won't get Donnie to host it, and where else is he going to take it to? He doesn't have his
Right,
own channel to put it on anymore.
On Rumble or
right.
BitChute?
Yeah.
Yeah, bitch
I
shoot.
just want to respond to this
I
gentleman
was
in the
gonna
chat
say,
really quickly. I just want to say that A's philosophy definitely does not know the mathematics and probabilities involved. I mean, I hear this argument for
Yeah.
abiogenesis mostly, but here he's doing it for evolution. But I just want to say that whatever math that you think that you're using to calculate the probabilities, maybe you should question that math and whether or not it's valid a little bit harder.
So
Well, come in here and
usually
talk
when
to us.
okay,
yeah, well, come
Sorry.
on and
what's
I
the
talk,
want a
guy's
guys.
creationist
next
in here so
comment?
bad, guys.
Well,
You guys
usually
are
Yeah, I
when
cool and
can't believe that no
everything, but
creationists has
yeah,
joined.
well, usually when they talk
Hmm,
probability, they're talking about Bayesian analysis. They're talking about Bayesian probability. Now, Bayesian probability is basically based upon if you have certain things that you allow for to start with. So, if you make certain assumptions, what's the probability that stems from that? And so, Bayesian analysis relies very heavily on getting those first assumptions right. So if you are
right.
doing a Bayesian probability study that says, hey, God exists and God wants to create something, yeah, the probability of a Bayesian analysis might come out very, very low. But that's assuming it's sort of begging the question that God already exists and God already wants to create something. They do it a lot with whether Jesus was the Messiah kind of thing. They quote this Bayesian analysis, but that Bayesian analysis assumes that God is real and that he wanted to get his message to people. Richard Carrier famously did another study which didn't make those assumptions, and the Bayesian analysis said that the probability is that Jesus didn't exist at all. So Bayesian analysis only works if you know the as Leo mentioned the priors like that led to it, and without that it's just meaningless. It doesn't mean anything. So
This is slightly off topic, but also applying Bayesian analysis to the idea of phylogenetics and common ancestry. Um, and in fact, Dr. Zach Hancock, who I suggest everyone go watch his videos and subscribe to him. He does some really good
I second
uh,
that.
yeah, stuff over there. Yeah, I think you've had some discussions with him, Grayson.
He's come on the
Yeah,
Aftershow before, yeah.
yeah. He let's see. I don't think it was a relatively recent video, but he did do a video at one point about um how it's usually kind of granted that nested hierarchies in functional genes, oh, that could just emerge by common design. But what he did, and what I think he did really well, explained really well, was the idea that kind of the basic logic behind phylogenetics even is taking Bayesian analysis, for example, or Bayesian methods, like you were saying, Mark, applying these priors, saying, okay, if we assume, for sake of argument, that these organisms really are related to each other, what should we expect to see in the functional genes? We should expect these patterns that, lo and behold, we do see. So we can tell, even within functional genes, that some kind of common descent did in fact occur. So I hope I'm making sense here, but
Yeah,
yeah,
is it
So
I
really
Zach
quick,
suggest
B.
everyone go watch
Hancock?
the original video there. Yeah,
Sorry,
he's
yeah, I
much better than
second
I.
that. Really
is
quick,
it
I
just
I know
I
A's
just
Philosophy
have
just
to
joined. I'm gonna
clarify.
introduce him.
Yeah, just have to clarify. Is it Zach B. Hancock that you're talking about?
Yeah, Zach B.
Yeah.
Hancock. Yeah,
So he's a
Okay, yep,
population geneticist,
yeah,
and
he's
he
an
makes
yep.
really
actual
great
population
content.
geneticist. Yeah.
Yeah,
Subscribe.
so he's a population geneticist, makes great content. I'm going to introduce A's Philosophy, who just joined, but before that, I'm going to read two comments really quick. One is by a guy named Mitchell, who already said that we know nothing and are clueless, and he said he's going to leave. That was about 15 minutes ago. I guess he's back. He wanted to tell us that the only cult is Darwinism, forcing their belief that we're all related to coconuts and squids with no evidence whatsoever. Clowns.
Darwinism
So
hasn't been a thing for
I want
100 years.
to say,
Yeah.
if show compassion for your fellow brother in Christ, join the live stream if you want to get into it. Help out A's Philosophy. He's here on 4 against 1. Help him out if you think that we're really clowns and that there's no evidence for common ancestry. And then really quickly, I just wanted to highlight one other comment. Mark, I believe that this one is for you, but I cannot be
I guess
sure.
so. No hair
But
guy. Yes. Yes.
somebody is very well spoken. So,
Yes.
on that note, Ace Philosophy, welcome to the after show. Is there anything on
Hey.
your mind? I know you were in the live comments.
Yeah, thank you for having me on. I didn't see the debate, so I won't be able to comment on that. But
It's all right.
I made a comment about mathematics and probabilities, and yeah, I think I used to believe in evolution until I started learning more about that, and I just realized that there's a chance evolution is true, but it's just an impossibly small chance, and haven't seen any evidence that has refuted that since I first saw it, and maybe you'll be able to show me something. I don't know.
Well, why do you think it's a small chance? Like, what sort of probability study or sort of empirical observations did you put together for that to be the
Well,
case?
for evolution to be true, the the protein coding sequences that are found in the genomes of every living organism would have to have arisen over time by basically mutation selection mechanisms. I don't see any other way it could have happened. But when you take everything into account about like the number of organisms that have ever lived, the number of genetic mutations that would have been passed on in any realistic model during the history of life, it doesn't really come anywhere close to being getting close to searching the permutation space of these genome sequences to find functional genome coding sequences of DNA. I just
When,
don't think.
when you did these calculations, did you take selection into account?
Yeah, absolutely. So you can assume very favorable models for evolutionary theory, which is that basically every single every single mutation gets selected. It's still which is actually incredibly favorable for evolution. Like no one would assume that's the case, but if you take the estimated number of organisms that have ever lived, so even single-celled bacteria, everything, probably not including viruses. I don't think viruses are really considered the same class as living organisms. But if you take
Viruses
like
aren't considered life, no.
No, they're not
right,
living.
so excluding viruses, but including everything else, eukaryotes, prokaryotes, and those types of organisms, scientists have estimated how many of these things have probably ever existed. If you take every single one and say basically every single one of those organisms passed on at least one heritable new gene variation, it still doesn't come anywhere close to enough to find even a single functional short protein sequence in the DNA permutation space. So this is a huge problem because for evolution to be true, this would have needed to have happened countless, probably millions of times, but the numbers show it probably can't even happen once on a very
So wait,
small
wait, wait,
scale.
wait. Are you
No,
saying that when you add up all the mutations in the entire history of the Earth, that you don't even get one functional protein as a result?
Correct. Yes.
I don't
Yeah, I'm
think
gonna need
that's
to see your
true.
mathematics on that because I don't think that that checks out because we've literally seen
Listen, the
new functional
population
proteins
fine.
evolve before our eyes. So we've seen
Well,
that that math is not true.
I wouldn't say it's evolved before our eyes. I would say, like, are you
Yeah.
talking about
no, no.
give me an example?
Okay, an example is nylonase. It's an enzyme that
Oh yeah,
requires a
okay.
specific protein in order to break down
Mhm.
nylon. Now, we
Ranting.
saw
Nylon doesn't exist
basically
naturally, so it couldn't
it,
exist. Sorry, Mark.
right, it
Sorry, go
couldn't
ahead.
exist before because nylon isn't a naturally occurring substance. We found a bacteria that had evolved this nylonase in the waste outlets of a nylon factory. So it evolved that protein over the time it took for the factory to be there and spew this effluent into a pond, essentially.
Yeah, there's
Yeah.
also an example of a gene in HIV in tetherin that allowed the HIV to infect humans, and it actually involved 4 different independent mutations that had to come into place to create this. And we literally watched it happen. The evolution of an irreducibly complex system, a novel gene. We watched it happen in HIV.
Just want to say
Yeah.
hi to Leo before we move on.
Yeah, hi,
Hey,
Leah.
Howdy.
Yeah, sorry, I'm being a
I
rude
just
host.
I just had a quick question for A. I'm just gonna call you A if that's all right. If not, let me know, please.
Hey.
What do you mean when you say
Hey.
that, like, so you were saying that, like, if we take all these processes, we still won't get a functional protein in the amount of time that not it would take even longer than the amount of time that evolution has supposedly been going on. Was I hearing you
Yes.
correctly?
So if we assume a 4 billion-year-old Earth, which is about what scientists say, if we go with all the
4.6,
current scientific assumptions, and I'm willing to do it, I do believe the Earth is probably very old. I believe that the Earth is at least millions or probably billions of years old. And you assume the normal time frames of life evolving, around 3 billion years ago. And you take every single, prokaryote or eukaryote that has ever lived, and it's mostly going to be prokaryotes, and you assume very favorably, for evolutionary theory, the numbers still uh, don't come anywhere close to being sufficient to basically create a novel protein. So I've heard the nylonase example before,
Mhm.
and something I'm not clear on is whether this isn't something that actually already existed in the organism, but just wasn't utilized until nylon came around. Because nylonase could theoretically have been a pre-existing protein with a different function that also serves to break down nylon. So I don't know. I haven't looked into it, but
Well, you can. I mean,
that
there's a
seems to me
paper
like
on it.
something that could be a possibility.
Yeah, I'll just show the refutation that resident genius in the chat, Mitchell, has put, where he put nihilase in quotations and then added lol at the end of it. And honestly, I just don't think that we can come back from that. I don't. He's
I
kind
actually
of
like
That's an
the way it's
airtight
presented
argument.
there. It sounds like something you're going to put on a sandwich when you say it that way.
Yeah, so I think that I'll say this. Okay, from what we know about nihilase, we know the type of gene family that it evolved from. We know the plasmid in which it mutated and came from within the host genome. And we know what the other species, like what the rest of the population of this organism look like, and they do not have the nihilase gene. We can identify which exact mutations occurred in which exact plasmid in its genome occurred to create nihilase. So we know where that mutation happened, and we can compare it to other populations that don't live in the same area. but they are the same species and they lack this gene.
So let me ask you a
So,
question. Is this myelinase? And I'm learning here. I'm trying to find out information.
sure.
Is it like the result of a couple point mutations, or is it a completely de novo, like different, like new folds, new protein folds? Like how different is the sequence from the previously existing organisms?
Why does that matter though?
Because well, scientists do know, and this is clear that point mutations do occur.
I
So
believe it was a frame shift mutation followed by some point mutations that
Yeah.
increase its
okay,
efficiency.
so I can, yeah, so those things can absolutely happen, and they do happen. There's no denying that they happen, and anyone who denies they're happening is just denying reality.
Well, I'll just
Like,
say one thing really quick is that this was so different from the genes that it evolved from that when it was first identified, the scientists had no idea what gene family to even include it in. It was only in decades later of analysis that we found out the actual mutational pathway that created myelinase, and we found out which gene family it evolved from. But at first, it was so different that it was designated as a novel gene family.
yeah, I can actually see that kind of happening, and we can see it. We can kind of also see it happening at the morphological scale with these, like a good example is the fish without eyes.
Okay, so then mathematically, then your argument about how the total amount of mutations that have ever happened ever cannot account for a single new novel protein, we've just shown that empirically that's been demonstrated not to
Well,
be true.
Do you mind
not
if I ask
necessarily.
something, Ace? Do you mind if I ask
Y-
something? Have you
yes.
actually engaged in any kind of probability study or mathematical model for this sort of claim that you're making, or is it something that you're just basing on intuition?
Well, the mathematical, the demonstration of the mathematics that I'm familiar with comes in. There's a number of books that have been written about it. Like I think the earliest one was Michael Denton's Evolution, a Theory in Crisis, but also more recently is Stephen
Well,
Meyer's book,
that's a book.
Darwin's Doubt.
I mean, anyone
Yeah,
can write a book, Ace. I could write a
I
book about,
understand, but the
anything.
math. If you want to know what I think is the strongest demonstration of the mathematical improbability of call it Darwinian evolution, mutation selection, evolution, I think that those are the two of the best ones. There are others that are pretty
Yeah, but
good. I
they're
think
just
Michael P.
books. Like, I
I
could
understand that.
produce a book today and publish it that says that aliens definitely live among us and,
Can
the
I
probability
clarify
is
something
high.
about these studies?
Well, I'm looking at a study right now using the Markov model that sort of the probability, and that's in Molecular Biology and Evolution, Volume 26, saying that, there's a few models and the probability is not sort of a zero number. So I'm wondering where you're getting this because
Yeah.
papers that I'm trying to go through sort of disagree with you. But
Well,
go ahead,
the
Rational. Yeah.
okay, yeah, go ahead.
Oh, I was just going to clarify. So, would you happen, or do you happen to know if these studies or books or whatever you're citing here, do they model it in terms of a single lineage analysis, so to speak? So in terms of, okay, this gave rise to this, gave rise to this, like a sort of a linear progression in terms of protein space, or did they model it in terms of full on populations all living together at the
Yeah.
same time, all accumulating mutations at the same time? Like,
Individually unique mutations,
Um,
but yeah.
right, like
yeah.
Recombination.
how would
So
they
it's
factor that into account exactly?
basically, and it's been a little while since I've looked at it. It's basically, I think it's like almost like they made the models as favorable as possible. So yes, you can start it with a single lineage, and you can mutate towards a certain end goal. So they did try to take into account, like, mutation works by, like, you start with a certain limited function and then the functions improve over
But they're
time.
not but they're not happening sequentially, right? It's not like one after another. There's multiple mutations happening in a
Right,
population at
exactly.
once,
Right. So
overlapping.
basically, yeah. So basically, it's probability. So anything could theoretically happen, but this just looking at the likelihood. So um, they took into account, like, let's say you have a functional protein sequence, and whatever it is of a certain length. So proteins are made of, I think like everyone knows, proteins are made of amino acids. Usually they're between like 100 and 1,000 amino acids long. And they took a relatively short one, and they said, what is the permutation space for this particular sequence of amino acids? And not only this particular sequence of amino acids, but any sequence which could potentially be functional according to this like class of proteins. And they did these experiments where they did point mutations and found that if you do like 5 point mutations, then functionality breaks down. So they took that into consideration and things like that. When they
This was in
basically
a
found is
lab.
that, yeah, it's based on the work of a guy named Douglas Axe. And there's actually a
Oh
20
wow.
minute video on the internet called The Information Enigma.
So can I ask you
And
something really quick, as
well,
if we were going to do this for a snowflake, right? We find a snowflake, we pick it, and we say, what is the probability that this exact shape snowflake developed whenever we froze this condensation? And you could calculate that it would be very, very small odds that that exact shape of snowflake would have developed. Does that mean that it's mathematically impossible for snowflakes to form? I mean,
here's the problem for proteins. The better analogy for protein function is words, because the amino acid sequences basically function as letters in the words that are the protein. So a better analogy would be like kind of like monkeys trying to type Shakespeare. Like if you just randomly smash buttons on a keyboard, how long would it take for you to get a meaningful sentence or a meaningful paragraph? Is a
well,
Sorry,
no,
better
this
way
is
of
why
putting
they
it.
asked the clarification earlier about whether or not these simulations were including selection. Because if they
um,
are including selection,
Yes,
that's
they
going
are.
to drastically change the calculation.
and plus, I just want to say something. Plus, the whole point of that example that you gave, like an infinite amount of monkeys smashing on keyboards, can write Shakespeare. That's the whole point of that.
I think
Yeah,
that he's
so
saying that we haven't had enough time in the history of Earth for the monkeys to type Shakespeare in his
Well, I'm
analogy.
not sure why he's
But
Yeah.
bringing up that analogy, because the whole point of that analogy is that if you have an infinite amount of monkeys smashing on keyboards, is that you can produce
that's the
Shakespeare.
point, is that you have an infinite amount of time, or you have an infinite amount of monkeys. In real life, we only have a finite number of mutations in the history of the Earth.
right.
So that's what he's trying to say. But I just want to say, like, if you had selection, right? If a monkey accidentally hits the right letter and it's in the right place, then
Right.
that stays. Then monkey's no longer
Yeah,
guessing for that
and
letter.
that was taken into account, because what proteins do is they're basically there's functional sequence space surrounded by a much larger, like if you take a sequence of proteins that form a functional a sequence of amino acids that form a functional protein, um there's actually function
Yeah.
outside of just that specific sequence. So these are these are when point mutations are introduced. We can see that many proteins still function. So they take into account like what is the range of potential sequences which would give any sort of function whatsoever, which would then lead to a selection mechanism where over time the protein would evolve into basically complete
Selection is the
efficiency.
mechanism, though.
Selection
Selection is
is.
Right,
the
but
mechanism.
the problem is this. You do have to at least get to a point where there is some function, and
They're already
that is
functioning.
actually very difficult, because the permutation space for functional proteins is much, 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 fractionally smaller than it is for function. Uh,
So the
that's not.
function that's required is going to be propagation. Anything other than that is
But
additional
Yeah,
function,
I'll
right?
just say
can
that
I
It just needs to
clarify
be able to
something?
propagate, and that's it. If it has that function, which it did, the only ones that survive have that function. So it's
Hmm.
kind of
Yeah, I'll just say that a
tautology
lot
to
of
circle back
organic
around onto itself.
molecules I'll just say that a lot of organic molecules have function, but that function has a fairly robust relationship to the sequence of the amino acids. So they demonstrate a very similar function regardless of the specifics of the sequence. I don't know how you would account for such robustness. Like amyloids are a good example of this. Amyloids can store information and they can self propagate under a huge amount of different variations in their sequence.
Well, I think that's why we a really good reason why we should focus on proteins and amino acids is because it's coded in the DNA, and they are absolutely necessary. And the sequences that code for these proteins are absolutely necessary. They would have had to have arisen by some mechanism. So we can establish a mathematical model that asks how probable is it that these sequences arose by selection mutation mechanism, and
Wait,
it is.
can I
Yeah.
clarify something? So when you said earlier that they were evolving this function, it kind of sounded like you were saying that the models they were making assumed that they originally had no function and were gaining a function. Like they didn't have a different function in the past, for example. Is that what you're saying? That they were
Well,
that's how they were phrasing their analysis?
yeah, a vast majority of proteins would have arisen from sequences with no function, because if you think about like a bacteria, it's going to have its let's try to think of a hypothetical original organism, bacteria, with a simple genome. If you want to get from that to a human, you're going to have a lot of copying of neutral DNA sequences and mutations of those spaces, which will then hopefully arise into the types of proteins that would be useful in humans and others similarly
I
complex
I don't think that
organisms.
that's a
I don't
valid
think that's how that
assumption. I mean,
works.
a
No.
huge amount. I don't know what proportion, but a large proportion of new like alleles arise from a duplication of a pre-existing gene and then like differentiation from that duplication. So it's not like they're just coming out of just totally random noise
Right.
in like
It's not
the
all coming from neutral junk
Yeah,
DNA, so
yeah.
to
absolutely.
speak.
But the problem is you do have to get that original allele, that original sequence. And
Sure.
like I said, if you just think of the original organism, whatever it was, a single-celled organism, to get from that to a human, you'd have to admit that a number of different classes and types and folds of proteins would have to have arisen de novo at some point. Like
Well, we
No,
just
it's
gave
just
you
I don't
several
think
unavoidable.
that's a valid
examples
assumption.
of new gene families arising from
Hmm.
like different types of genes. Like myelinase was a great example of this. Like we've
Right.
watched this happen. We know it's not mathematically impossible.
And plus, once the
New
Well,
protein
protein
fold
families come from
occurs,
pre-existing ones.
and once it
it
occurs,
can
it's
happen.
relatively stable. Like this is the thing. Like this is the selection. It's relatively stable. Once that protein occurs, it is a relatively stable thing, and that's the whole idea behind selection that you're sort of missing. I don't
Well,
understand where you're getting the probability of zero over the entire course of human history. I don't understand that.
it's not zero, but it's 1 in like 10 to like the 100th, which is basically zero.
Yeah, I think we're just expressing skepticism on your math and of how you're getting to those
Yeah.
probabilities
Yeah.
So
because
if
I just think that they're not valid.
well, let's
Well,
okay. Let's say
without a
okay.
specific study,
Let,
like we're kind of just talking about vague claims here, if that
all
makes
right. Well,
sense.
I will get more specific. Let's say
Yeah.
you're talking about a specific protein of 200 amino acids in length, and scientists have found that that a lot of proteins are very specific. You can't have too many point mutations before function fails. So let's just say there's like average 3 or 4 in 100 protein amino acid length. So that's your range. So when you
I'll
have
just say that that's not accurate. Like for most
Yeah.
proteins, they're fairly robust in their sequence, and like oftentimes more than 50% of the protein can mutate without any
Right.
noticeable change in function.
Hmm.
I mean,
If
okay,
you
there are
the way
mutate the
that
problems.
active
proteins work
site, for
the way
example,
that
with an
proteins and
enzyme,
enzymes work
right?
is that
Yeah.
they have active sites.
Yeah.
Certain
Exactly.
positions in the sequence are more important than others, and the
Right.
majority of the amino acids in the sequence are not very important to the overall function. So you have a robustness to handle lots of different mutations.
Okay, I mean there's going to be cases where that is true. I don't deny that, but there are also cases where, you have amino acids proteins thousands in length, and they can only handle a couple of point mutations or they
Some of
fail.
them,
This
yes,
Like
but
this
what?
not the
is
majority of them.
again, I may be wrong about that, but this is the information that I've
Yeah,
seen.
okay. Okay.
So, Yeah, and I don't doubt that there are cases where it's much, much more than that. But I'm just giving like a hypothetical example. So
Sure. Okay, you
each,
can continue. I didn't mean to interrupt, but
each
I just had to say that.
so there are basically 20 amino acids that are used in living organisms. I think that in some instances there
Yeah,
are
we can
many
agree with that.
different. So when you start looking at the permutation space of 100 basically instances, each with a possibility of 1 out of 20, and you can't really mutate more than a couple of these spaces. The probabilities that's a sequence space where the fraction of failed sequences vastly eclipses that of the functional sequences. And when you start looking at the numbers, so like you have the 100 sequences, you have, let's say there's just, look at the first amino acid. It's got to be one. It's got to be the right amino acid out of the possible 20. So that's, you have a 1 in 20 chance. Then you go to the second one. It has to be the right one of the 20. So you take 1 over 20, and then you have 2, 1 over 20.
Yeah, that is
That's,
not how you would calculate these
well, hold on, let
probabilities.
me finish.
No,
So
that is
basically,
not.
once already you're at 2 amino acids out of the 100, and the chances you're correct still at this point is 1 out of 400. So 20 times 20 is 400.
Because that's not how this works. Like that's
Well,
not
Plus,
how proteins are formed.
in a lot of proteins, you can substitute one amino acid with another, and it will have exactly the same function.
I understand that,
Well,
but
no, my broader point is that this is not how proteins are constructed. They are not constructed one amino acid at a time.
I
Like,
I recognize that's not what I'm arguing. You have to see what I'm arguing. All right, let's just simplify it. You have a protein of 2 amino acids, and it has to be the two. Like I don't know the names of the amino acids anymore, but let's just say that in the first spot of the two, it has to be one of the 20. There's only one possibility to make this protein function.
sure, okay.
So that's, you have a 1 in 20 chance in that first spot of being correct. The second spot, it also has to be perfect. It has to be the right one. So that's also 1 out of 20.
But you say that you're not
Well, hold on. Let me
calculating the
finish. So I'm
probabilities
in
for a
this hypothetical.
scenario in which the amino acids are randomly coming together to build
I'm
something. But
not
that's
trying
what
to
you're
Right.
calculating.
I'm just giving you the theory behind the mathematics behind the probabilities.
But
That's
The
not the
we've
the
mathematics
already
protein.
behind
made
the
so many faulty
probabilities.
assumptions about
I
protein
know.
Yeah.
formation that are
I'm
not
just
true.
creating a very simple, non-realistic, hypothetical scenario that has nothing to do with reality. I admit
Okay.
that.
As long as you put that disclaimer that it's not realistic, I'm with you.
Okay, all right. So basically, what is, if you have a protein, 2 amino acids in length? What is the probability if you just randomly select amino acids from a giant pool of amino acids and put in one,
One in
two?
400.
It's 1 in 400, correct? So when you start getting to a normal length of a protein, which is like 100 and sometimes more, thousands in length, those numbers are astronomical after so long. So you can see how, if we assume that the sequences are very specific, which they many times are, how hard it would be to for an evolutionary process to search the sequence space to find the proper sequences. And this is the problem I'm seeing with evolution in terms of
I
No,
thought you
predicting.
said you were
if you're
taking
doing an
selection into account.
unrealistic, you just admitted it was an unrealistic model that you were using. Why would we pay
Well,
attention to the probability and say, oh, that's against evolution, when you
because
just said,
it does that scenario, that exact specific example was unrealistic. But when you do start getting into the real world application, the numbers actually do still seem to be very bad, because those
Okay,
that's
probabilities.
ridiculous?
what is the probability that you formed in your mom's womb, right? If we take every atom in your body and calculate what are the odds of each of them coming together in the exact sequence to make baby you in your mom's womb, we would conclude it's mathematically impossible for you to have been born. Like, that's why if you
Well,
calculate probabilities for an unrealistic scenario, right? That's not how birth works. You're not ordered atom by atom. So calculating the probability of you coming together atom by atom is a total non sequitur. It doesn't make any sense to calculate
Yes.
that probability and to try to ascribe it to the real
well,
world scenario of how you were born.
So that's why I want to point out that the papers that I'm seeing calculating different probabilities than you are, A's. It's because they're using an accurate model and you're using a highly inaccurate model and think you've got some kind of gotcha because you've got this incredibly inaccurate model. You're projecting that. And I mean, I realize that you're saying, hey, but still in the real world, it would be hard. You're projecting your highly inaccurate model to the real world and then expecting it to be evidence against evolution. I'm really sorry, mate, but if you're going to use an inaccurate model, you're going to get inaccurate results, even when you project it to the real world.
Yeah. So all right. So the chemistry, underlying genomic. Well, the problem with the problem Titan Uranus, great name. Is that when these mutations are occurring in the DNA, there's nothing that specifies, which nucleotide will go in which point. So the mutations are random. The sequences that they will generate on their during the mutations are random. It's not like the structure helps in any significant way.
Not really. I mean, for mathematical models, we can say mutations are random, but in reality, certain mutations are more likely than others, both in location, there's hot and cold spots of the genomes, and in the specific type of mutations, like an A to a G or an A to a T. Like the probabilities for these things are not equal. Like it's slightly nitpicky, but they are not true random.
So, how important is the geometric shape on that, Grayson? I just to clarify what Titan was saying there about the geometry of the.
Yeah, the geometric shape is immensely important for pretty much all enzymatic activity. The actual shape of both the
Mhm.
active site
Well,
and the enzyme as a whole is extremely important for how it's going to be like sent to where it needs to go, how it's going to interact with its ligands. Like the shape is the key. So as long as, and these shapes are fairly robust. They can take a large amount of mutation and still have the overall same shape as
Yeah, that's what
long
I've been
as
reading.
like there are certain key amino acids in the sequence of the protein that are key to that shape, like certain lynch points, And as long as you have that basic skeleton, like the rest of the amino acid identities don't really matter that much as long as they're not interfering with the overall shape.
I don't think that's correct. That's not what I understand. And again, I'm not an expert, but from what I understand, you can't just you can't there may be instances of it. I won't deny that. I don't have an
Pretty
exhaustive knowledge of
unlikely.
this, but from my understanding, many proteins, or maybe even most, can't really sustain that many point mutations before their function totally degrades. So that's probably an area where we're going to disagree, and that would be an area to question and find answers that I would like
Well,
to,
the funny thing is, Ace, I mean, I'm reading the same thing that Grayson is saying on these papers that I've pulled up. That the more highly expressed a protein is, the slower it evolves because of the both strength and universality of this effect. It requires an explanation that applies in any organism, is consistent with protein biophysics, and is capable of reproducing the key patterns of sequence variation observed in natural proteins. So I'm reading the same thing he is saying from a paper on this paper is biophysical models of protein evolution, understanding the patterns of evolutionary sequence divergence. Julian
Well,
Avaj and
and
Claude
listen, I don't
Zervilke.
want to.
Well, I just want to say one thing really quick. So,
Okay.
the papers and Grayson and everybody is sort of saying that what you're saying isn't true. And you're sort of leaning on this stuff you've read in books published by anti evolution people. And I don't know why we should sort of believe that when you've sort of misrepresented, not maybe not intentionally, but misrepresented how these proteins come together and how it actually occurs. So why would we believe you over the documented papers, the experts that have written them, and things like that?
Yeah, and I don't want to pull credentials here, but I do just want to point out, I mean, like I don't think I've said this on my channel before, but I did used to work in a structural biochemistry lab where the whole what we did in the lab was we took out like parts of proteins and substituted them with different parts and observed how that affected their structure and how that impacted their function. So literally I have done the experiments on this exact subject. So I'm not at
Nice.
a PhD level of expertise here, but I do know a little bit of something about what I'm talking about.
Okay, well, I guess what I would have to do is do more research on how many mutations, specifically point mutations, a DNA sequence can sustain before its protein loses function. I know that you are correct when you say that it can be a significant amount, but I also do believe, like um like I'm reading. Okay, this is Wikipedia. I don't really like Wikipedia all that much, but like if you go to the article on point mutation, it says most proteins can withstand one or two point mutations before their function changes. So
But
function
that's
changes
functional
does not mean,
change. Doesn't
yeah,
mean
that does not mean
collapse.
ceases functioning, but we can
Right.
see most proteins are between like 100 and 1,000 amino acids long. With one or two, you're already getting a change of function.
Well,
And
what you
But
just
that's not a
read said that
collapse.
most don't have a change of function with 1 or 2.
uh
Like, did I miss
it's
the part where it said
it's
after
okay,
3
this
or
is what
4
I'm
they
reading.
start having a
It
bad
says,
impact or
this
what?
is what it says. The article is called Point Mutation, and where it says is most proteins can withstand one or two point mutations before their function changes. Um, and then it goes on to say, two sentences later, the protein may lose its function. So again, this is Wikipedia. I'm not sure what this source is, where it's citing that, but so take it for what it is. But
Now, Wikipedia should have a source.
yeah,
There should be a source on there.
Again, this is
So
an area of study that would be interesting. The last I checked, there are proteins. I'm quite certain about this. There are proteins that even a couple point mutations destroys their function. So those do exist.
I
I
mean,
think
sure,
I'm safe
yes,
in saying
Yeah,
that.
yeah,
some of them do
every
exist.
protein is like that. It just
I
depends
have
on where
worked
the
my
point
butt
mutation
off to make
occurs.
Wikipedia something that's viable. So it's not 2006 anymore. We should have all citations on there. Just throw that out there.
Yeah, big
Okay.
fan of Wikipedia. Everyone should donate to Wikipedia. Big ups to
Mm.
them. But I'm just saying, it depends on where the
They're
point
biased.
mutation occurs, right? If you have a point mutation in the active site of a protein, of course, you only need one point mutation to impact its function. But the majority of an enzyme is not that functional to its like
Well, here's
role.
the
Like
problem. The reason one or two point mutations can make a huge difference is because it completely shifts the frame of reference for the rest of the protein, and the proteins have to fold in a specific way.
that's a
No,
frame
not
shift mutation,
necessarily.
not a point mutation.
Yeah.
Well, a point mutation can create a disturbance
Yeah, but you're
in
talking
how
about
the entire thing.
specifically changing one amino acid out for another amino acid. So you're already
Out,
talking
out of
about
hundreds, like you
downstream
said.
from translation.
All right. Yeah. Okay. That's correct. I'm trying to do research on the fly here, and it seems to me that
Yeah,
there's
no problem.
a wide variety of types of proteins. Some of them are very
Well,
specific,
absolutely.
and some of them can
Honey.
tolerate a larger number of mutations.
Yeah, it's true. I don't need to gang up on you or whatever. I mean, I know that
Yeah.
you're the only one versus
Yeah.
4 others on the other side. I mean, some of your creationist friends need to hop in here and help you out maybe, but
Yeah,
I'm not sure.
maybe.
I'm not sure if there are any more out
Well,
there, but
it also mentions in this Wikipedia article that evolution is sort of the causes of evolution and point mutations in evolution. So why is it that you're
well, of course.
taking sort of well, why is it that it's believable on one or two point mutations causing a change in function, but it's not believable on evolution? Why is that?
Um, because if you think about how the process would have had to unfold in history, you would
Well,
have had to go to a point where certain proteins don't exist to existing. And really, there's only one way this could have happened, which is through some sort of mutation selection mechanism. And you would have had to go from these protein families, these fold classes not existing at all to them existing. And
isn't that
sometimes you only have one or
abiogenesis?
no, it's not abiogenesis. So
no,
like
I mean
let's
he's
say
talking about the creation of new genes by
Oh, de
mutation, but
novo
I think what
yeah,
you're
okay,
failing to
gotcha.
account for is that these are mutations of pre-existing genes and proteins. Like
No, well, sometimes they're not, because there are almost every single organism on Earth has proteins that are specific to its own type,
Yeah, and
or
those
mutation.
derive from pre-existing
That's not true.
proteins.
Some
They don't just come out of
I
nowhere.
forget what they're called.
No,
They're called, actually there are
You're talking about
proteins
orphan
called,
genes.
right. There are orphan
Yeah, and
genes, and
orphan genes don't just come out of nowhere. Like they don't just come
well,
from
some of them
nothing.
do. That's the
No,
problem.
I'm sorry.
they result
I'm
from mutations of pre-existing genes.
I'm really
Okay,
confused.
well,
Weren't you the one arguing that no new proteins have formed, and we sort of pointed out a few examples of them?
Well, we can't assume that these orphan genes evolved. That's the whole problem. Is
So,
you have these incredibly complex biomolecules which just are apparently there, and how did they get there? Could they have happened by some sort of just de novo mutation event? And the answer is probably not. No.
well,
Even though
I
we've
think it
shown
is.
examples of that exact thing happening.
Yeah, and I guess
Well,
that
again,
doesn't answer my question of how you can tell one part of Wikipedia is correct and the other not. If you're using as a citation, you're using that as sort of this is demonstrating the truth of what I'm saying. But I'll pass that up. So if it did not happen by mutation, as the papers and all of the information we've given sort of says, how did it happen?
well, it would have had to have happened by some sort of intelligent design, in my opinion. I don't see any other
Okay.
way.
Okay, and so
Because
what evidence do you have? Like we're presenting all of this evidence that hey, this probability isn't the same as what you're saying. There are other factors involved. There is a structure that sort of predisposes these proteins to forming the geometric structure. So what do you have for us that shows that a god created these things?
well, honestly, I recognize that there are instances where these things can be demonstrated, but when you start looking at everything that's out there, there are a lot of things that can't be explained by evolutionary mechanisms. So it's like, how did this happen? Did
Like what?
It couldn't have happened? I can't think of any naturalistic mechanism by which it could have happened, but like
Is there an
intelligence,
example?
yeah, these still talking about proteins and DNA sequences. That
I guess
it's possible.
even if it were the case that it wasn't done by evolution, that doesn't get you one step closer to a god. Like you
I
have to
also have
have
to ask.
evidence
It invalidates
for
the
a
if you
god.
can.
Not no, let me finish. It doesn't. You need evidence for a god, not against any other theory out there. Like you need to demonstrate that a god in fact did that, or else if you're going to be intellectually consistent, you could argue that hey, it could have been magic, it could have been aliens, it could have been any number of things. But you've decided on a god, but you don't seem to have any evidence for a god. You seem to want to just say, hey, I have evidence against the scientific consensus.
Well, I don't believe I ever used the word God. I do believe I used the word intelligence. So an intelligent designer. So that there are intelligent design proponents who are atheists and who believe it maybe have been atheists. I
So
can't
I
think of
just
their
have to
name.
ask then, you believe that Nilanase was already existing within like this was designed by this intelligent designer and already existing within the genomes of these bacteria. So my question is how intelligent would it be to create a gene for decomposing nylon but not create genes for decomposing, I don't know, plastic or, a bunch of other problematic chemicals that we've leaked into the environment. Like if the designer had the foresight to create Nilanase to handle nylon litter, why is it that we only find Nilanase among a very small population of bacteria that are showing a gene that's different than the rest of their species? Like the rest of the species doesn't have that gene. So why wouldn't all the genes have it or all the bacteria have it? And then why don't we see, oil spills or plastics or other kinds of litter and pollutants? Why don't we find that this designer had created a solution to where we're not polluting the planet that they designed?
Well, I'm actually willing to accept that Nilanase occurred entirely naturally in the recent history by a genetic mutation event, because these things are possible. They are within the realm of possibility.
But
Um,
your whole argument is that It's not. You said that if
Right.
you count up all the mutations that have ever happened in the entire history of the Earth, that you don't have enough mutations to account for even one beneficial gene.
Well,
So if you're acknowledging that in Nilinase, it seems like you've refuted your first claim.
well, we have to look at every specific case. Do I think Nilinase could have just formed de novo from a completely neutral sequence to a functional sequence? No, but what you described of a frame shift and a couple point mutations, that seems incredibly likely to me and could have very well have happened within life's history. I have no problem believing that. Just like I have no problem believing that fish lost their eyes over the course of a million years when they got stuck in caves. Like these things do happen,
Well,
but that's a lot different than saying like a fish evolved from like a prehistoric clam or whatever.
Well,
It's,
No,
it's a
no
difference
way.
in
the
scale.
problem here is the time element, because you're saying, okay, a point mutations and a couple of a frame shift mutation, a couple of point mutations produced Nilinase. That you can believe that, but the problem is that nylon was only invented in 1930s, and its structure of Nilinase is totally different than anything we've seen before. It's totally different than what it evolved from. So when you go, oh, well, that's the product of, less than 100 years, 90 years or so, um, you then take into account the 4 billion years that you were saying earlier, and suddenly your probability thing does not look so unlikely. If Nilinase can be developed or evolve over 90 years, what can evolve over 4 billion years?
Right, and I do think that gets down to the specific case of Nyland's. Again, I'm not an expert on this, but if
Sounds
it
like
is the
special
case,
pleading to me.
well, here's the thing: if it is the case that Nylandase is the result of a few simple mutation events that did result in a new class, but nevertheless did form from pre-existing functional sequences which underwent a couple, mutation events, a frame shift, and a couple of point mutations. That is very likely to have happened because of how many organisms there are. These bacteria, their numbers. I can see how that a mutation like that would happen, but when you start trying to explain more significant accumulation of genetic material, even in 4 billion years, it's the again, it's not impossible. It's just almost unlikely to the point of impossibility or improbability.
You've already admitted that the scenario for which you're using to construct these probabilities is not realistic. And you've already
Unrealistic.
admitted that we've seen examples potentially of new genes arising from mutation. So honestly, I think maybe I'll let you, get a final word in or whatever. But I did want to switch the topic here because rational empiricist was interested in discussing Big Bang cosmology coming up for my next debate. So I did
Mhm.
want to allow a little bit of time on that and not just have him sit here for
Is that why Leo
multiple
left?
hours before we got to it.
Do you think he
Okay,
wanted to
yeah.
discuss it?
Well, thank you for having me on. I just wrap up in a minute or two here. If anyone is actually willing to see a more thorough examination of this, I recommend looking at Stephen Meyer's book Darwin's Doubt, or there's a 20-minute YouTube video put out by the Discovery Institute called The Information Enigma, and it explains it a lot better than I ever could. And I also have a channel, A's Philosophy. I talk a lot about Christianity, which I'm not sure would interest anyone here, but I do believe Christianity has been corrupted. What is currently presented as Christianity is not what was originally taught. So if anyone's interested in converting to Christianity at some point, just realize that the modern offers are not exactly what was originally what taught by Christ himself. So hope you'll all be willing to look into that, but otherwise you all have a good whatever it is for you, evening, morning, night, or whatever.
Thanks, A's, and I do appreciate you coming on. And you're the bravest creationist of the night, so I appreciate you for coming on and having the discussion. It's
Yeah, thanks.
Yeah,
Thanks,
thanks,
Ace.
Ace.
All right. Yep. Thank you all. Bye.
sweet. So Yeah, for those of you that missed it earlier, I'm going to be having a debate on on Big Bang cosmology coming up on modern day debates. So, rational empiricist wanted to use his previous experience with debating my debate opponent on the same topic to kind of offer up a few pointers. So, I'm definitely open to hearing from him. So, I'll open up the floor.
Yeah. So and anyone else can chime in if they have questions or if they just want to discuss some of this. I'm
Yeah,
by
I
no
don't know,
means an
Mark
expert
and
in
Bree, do you guys
cosmology. Right?
do debates on the Big Bang?
Sure.
I have,
I'll
yeah.
debate anything. You should know that by now, Grayson.
Yeah,
Yeah.
I think
fair.
one of my first debates was on the Big Bang with Otangelo Grasso of all
Or
people.
really?
D'Angelo.
I didn't
I
know
haven't
that.
seen him round for a while, actually. I wonder if he's okay. I
No,
hope he's
he won't
okay.
come around me
Yeah,
anymore
he
anyway.
pops his head in
He
every once in
told
a while.
me that he would do a debate on abiogenesis, and he was telling Donnie that he wanted to do it on SFT's channel, but then I wanted to do it on my channel, and I've had heard radio silence ever since I suggested it.
Why
Hmm.
should Donnie get all the super chats?
Yeah.
Actually, you're not monetized yet, are you? No, not quite yet.
Oh, good question.
252 though, you're getting up there.
Woohoo.
Oh,
And do
Yeah,
that's great. I've
subscribe
had
you're
if
a
you're
few
getting
not
new
subscribed.
pretty
subscribers
good,
just since
Grayson.
this stream began, so I very much
Mm.
appreciate all you guys, and also the fact that there are currently more likes on this live stream than there are viewers, or the same amount, or no, there are more likes than viewers. So I really definitely appreciate that. I don't know, I've never seen that before, so I very much appreciate all the support.
But do
Yeah, thanks
subscribe.
all
Like, what can it
for
hurt?
watching.
Just a button. Just hit it, and you'll never look
Feed
back.
the algorithm.
Feed.
You just
Okay,
listening
so
anyway. Come on.
Big Bang, Big Bang. So the
Yeah.
two major evidences for Big Bang are
Or well,
cosmic.
there's more than two, but
Well, the
yeah.
two major
So
ones.
You're implying the redshift and the cosmic microwave background.
Correct. Yeah,
Yeah.
they're the big ones. Yeah.
yeah, those are two of the big ones. Yeah. Yeah. So Sal, he has a slew of arguments he typically brings up, or at least he's brought up a number of times with me when, like, we haven't done a debate per se, but we have discussed some of these topics on a few occasions. So I think I'm relatively familiar with, because he does say this similar things uh, on multiple occasions. And I think Rebecca seems like bases her arguments off of his, or that he's kind of feeding her
Yep.
what she's saying, not to degrade her in any way, of course, but I do think that's what's happening is she's listening to him and him alone on this subject. But
So
that's
let me
neither here
let me
nor
lay
there.
out what my expectations are, right?
Sure,
Because
yeah, let's
um,
start there.
so basically, since it's a tag team with Leo Filius, I'm letting Leo take the reins because I've seen him summarize the evidences for the Big Bang before, and I think he does an excellent job. So with
Mhm.
my opening, what I wanted to do was specifically address some of the counterpoints that maybe my opponents would bring up. So
Yeah,
so far I wanted to talk about oh, how can you fit all of the matter in the universe in a very small space? So I was going to talk about quark gluon plasma and things that we've actually observed,
plasma.
and then I was going to talk about tired light. I don't know if they're going to bring up tired light, but you definitely have
Yeah.
more experience with Sal's arguments than I do. And then I was going to bring up like the I've seen Sal. The only time I've seen Sal make a video on the Big Bang was about the periodization of redshift and how it's not continuous. So I was prepping to address that
What,
argument.
I
when was
think I've
that,
heard
if I may ask, about like quantized redshift, or what you were saying? Do you know when he published that? I'm just curious.
Yeah, I believe it was last year, and
Oh, okay.
he was citing an article about four Indian scientists that were talking about the periodization of like the quantized redshift that they were supposedly observing. So that's the only time I've ever seen him bring up the Big Bang in a video. So that's why I wanted to specifically address that.
And would you be comfortable, just curious, giving how you were going to respond to that particular
Yeah,
argument?
so basically, there have been supposed observations of the periodization of redshift
Right.
since like the 70s. And typically, the problems, at least according to, I found a review article from 2022, so last year, about
Oh, okay.
the history and the data behind like the redshift periodicity, and their basic conclusion was that the data sizes that were used to make these observations were not sufficient, or they were
Yep. Yeah.
heterogeneously chosen, and that when you have a larger data set, the significance begins to decline. So when
Okay.
we look
Yeah.
at, more than just one cluster of galaxies, or we look at, when we include a sample size of all observed galaxies, we no longer see
Right.
this effect.
Okay. Yeah. Yeah. That's what I was hoping you were gonna say. Yeah. I think that's the main point you can drive home if he brings up that particular argument. Because yeah, with larger galaxy surveys, we found the um, redshift periodization uh, becomes less significant, like you said. I apologize, by the way, for my stuttering. It is getting kind of late over here, so I may
Yeah, no
mess up my
worries.
words here and there. But yeah,
Yeah,
um,
relax. It's no problem at all.
Yeah, hey man,
yeah.
if Joe Biden can get elected president, then you can absolutely kill it in this live stream.
Oh, thanks. Um, were you gonna say another argument or counter argument you were
I
going to
I want to bring
mention
up an
earlier, or
argument because I got to go soon, but
okay?
I want to
Oh, okay.
bring up an argument which is that and I've heard a couple of people say it. I don't know if Sal and Rebecca are going to use it, but it's sort of we thought galaxies were older, and then we found they were like they formed earlier from the
That's
James Webb.
exactly what I was going to bring up.
Really?
Oh,
Like,
Oh, great
people are
minds, my
something
loving
friend.
you
all
were
Great
this
hoping.
minds.
JWST
Yeah,
data and
yeah,
Yeah.
saying, but the galaxy formation is way too
Right.
sophisticated than we would expect. And basically, my argument against that is like, galaxy formation is not part of the Big Bang theory. Like,
right.
it's it's not really. It doesn't have anything to do. It doesn't change any of our observations about cosmic microwave background. Like, yeah, we don't have all of the answers and the dynamics involved in galaxy formation, but that again is not part of the Big Bang theory. Really, I
Yeah,
mean,
there are multiple ways to come at it. Yeah, I think that's a pretty good approach because on the first layer, galaxy formation, for one, is still relatively poorly understood. With that. That's why we launched JWST in the sky to begin with, for one reason.
Yeah.
But
I'll see you
also,
guys in the side chat.
oh, see you,
all
Bree.
right,
Fair
good. Thanks
Brie.
for coming on, Bree. It was great having you as
The
always.
beautiful Brie. Yeah, thank you so much. Sorry, go ahead, Rational.
Yeah, so the galaxy formation models, for one, aren't even part of Lambda CDM or aren't specifically tied to it per se. And by Lambda CDM, I just mean cold, dark matter, dark energy models of cosmology. And like you were saying, those models, Lambda CDM, is kind of just um, the simplest type of that kind of cosmology, if you want to think of it that way. It's involves the Big Bang, but it isn't the Big Bang theory per se. There are models that can incorporate the Big Bang that also involve dark energy and dark matter. They're just a little more complex than lambda CDM by itself. So at most, we could say that these JWST results, and this is assuming that the redshift observations, that their distances do turn out to be that far away. It hasn't been confirmed for all of them. In fact, it hasn't been confirmed for most of them at this point. Um, but if we grant that, then at most we can say, oh yeah, LCDM has to be tweaked a little bit. But that by no means, like you were saying, Grayson, touches the core of the Big Bang
Doesn't
as an
invalidate
idea.
it.
Yeah, because it
Well,
doesn't
Yeah,
at all change the fact that we have the cosmic microwave background. So like we can look up and
right.
know
Yeah,
at one
mm.
point there were no stars. Like we can see it in the cosmic microwave background. So it doesn't change any of the evidence for the Big Bang.
Well, it's also because of redshift. Like at a certain point, redshift goes into the infrared, like because it's shifting towards red. The James Webb is able to see into the infrared spectrum, which is why it's so amazing, right? That this is why the James Webb telescope is incredible. The Hubble didn't have that capability. So we put the Hubble out there. We couldn't actually see the redshift that made it over a certain level where it became the infrared spectrum. But
Right.
the James Webb can. So it can see these galaxies that we could never see before. So that is why the James Webb is amazing. And just for the chat, yeah, it's fantastic in Australia. Every day's a good day in Australia. Joe Rogan recently went on a podcast and said that Perth is gorgeous. Where I live, he's not wrong. I feel so proud, but yeah, it's gorgeous over here. Thanks.
Yes. Yeah.
Yeah,
So
so yeah, I
on
would be the
the
first
topic
one
of
to
the
admit
oh,
that
sorry.
early galaxy formation is a big unknown in astronomy currently, but it's
Yeah.
also like it's not within the early formation of the universe, which is the
Right.
Big Bang. So
It
it's
doesn't
like,
Which is
feed
an
back to the Big
exciting
Bang.
topic to be sure. Yeah.
and if they try to say that it's like, oh well, like you have to have the formation of galaxies if the Big Bang is true,
Right.
like sure, like you also have to. That doesn't mean that you have to explain every single thing in the world around us today, and that's part of the Big Bang. You
Right.
know, for like an apple for a Carl Sagan reference, an apple pie recipe is not part of the Big Bang, even though if the Big Bang is true, there has to be a naturalistic explanation for how a apple pie recipe came to being. That doesn't
Right.
mean it's
Yeah.
part of the Big Bang.
And I
Yeah.
think to
I just say
watch,
that like. Sorry. Go ahead.
I think just to watch for the argument from incredulity, like how
Yeah.
could this possibly have happened, kind of thing. Just that argument from incredulity. Just it doesn't. It's a logical fallacy for a reason. Just because you're incredulous of it happening doesn't mean it didn't happen.
So that's what I was going to address, because I saw Leo Phileas's video with Rebecca where they had like a 2-hour conversation on this.
Oh yeah.
And my main
Mm,
takeaway was that an argument from incredulity was her main argument.
yes,
And
yes,
she could
100%.
not understand how you could get all the matter in the universe into such a small amount of space. That's what she was incredulous about. So that's why I wanted to preempt that, but with a discussion of quark gluon plasma, and saying
Yeah.
that this was first predicted, right, in like the 70s and 80s. And it was predicted that if you bring in matter into a very, very small confined space, like then the actual quarks will break confinement in protons, and you get a state of matter called quark gluon plasma at certain high densities. And then we predicted that, and in the year 2000 we found experimental evidence that it does exist, and now we've had 20 years of measuring its properties. And so we know that in the very early universe, where you had all the matter in a confined space, this is not like a period on the size of a page or whatever. This is during the Quark epoch, but we know that you could fit it all into the area of the universe that was the size of the universe in the Quark epoch. Like, we have the
Yeah.
math, we have the experimental evidence to support this. Quark gluon plasma exists, and it answers this question.
Okay, well, make sure you
Yeah.
dumb it
I
down so,
concur.
like, a creationist or me can understand it, Grayson.
Yeah, I'll have to work on my delivery, but since it'll be a part of
Yeah.
my opening, I'll have it like written
Yeah,
out.
absolutely.
Yeah.
I'm a big fan of pictures and slideshow presentations. You know I am. I use them every single time. So consider doing that if you want to. But
Yeah, it's
I
just like,
got
I guess I would say, like, okay, so she wants it to bring up like a purse or a carton of milk or an everyday
right,
object. So I'll
right.
say, look, if you take that object and you continue to compress it more and more and more, and you put more energy into compressing it, eventually what you're going to make is a plasma, right? You're going to break down
Okay.
you're going to break down the atoms to where like they're no longer capable of forming like stable molecules.
Like in the
They're going to
sun.
lose their electrons. It's going to form a dense plasma. And if you keep going even beyond that, you're going to condense it down so much that the actual atom nuclei themselves break down, and you're going to have free protons and neutrons. And when you continue to compress it, even the protons and neutrons are going to break apart and break confinement, and all you're going to have is like a liquid soup of quarks and gluons. And this is like the most condensed form of matter that we currently know exists from experiments. Like, we have produced quark gluon plasma, we know its properties, and we know that you can condense matter down to a very, very small space when it's in the form of quark gluon plasma.
Is that quantum foam?
No, no.
No. Okay.
So we produce quark gluon plasma in particle accelerators. Um, like when we slam two particles at super high energies, they actually for a split second they create quark gluon plasma because the energy density becomes so high that confinement is broken and the actual protons themselves break down. So we've actually measured the properties and we've seen that actually it's interesting. The properties are almost like a liquid. So this stuff kind of behaves like an ocean of gluons with a few quarks floating around in it. But we know the properties of this. We have verified by experiment that it does exist. It was predicted by our current scientific models decades before it was found. So I think it's
Wow.
a very strong explanation for like to address the incredulity
Yeah.
of saying, we can
Yeah.
Novel
condense.
testable predictions. Yeah. Yeah,
Yeah.
absolutely. Yeah.
Yeah.
All right. Well, I got to
So
take
that
off.
that
I'm
was
so
the angle that I
sorry,
was going to
Grayson,
go
but
back on.
I got to go. But thank you so much for having me on. It's always a pleasure
Thanks,
to
Mark.
speak to you. Rational, it was a pleasure to speak to you as well, mate. Do you have a
Oh,
channel or
likewise.
something, Rational?
No, no, unfortunately not. But
Okay.
I do hang out on Answers in Atheism and other channels
Oh,
sometimes.
Speed of Sounds. Yeah, okay.
Yeah, Speed of
It's
Sounds.
just
Yeah,
the time difference trips me up for Speed of Sounds. I've wanted to go on his
yeah.
channel so often, but it's just the time that we can't seem to mesh up. And he's a great guy.
That's a
I like
shame.
Speed. Yeah, it is. But it's so good to hang out with you guys, and thank you so much for having me on. Have
Yeah,
a good
thanks, Mark.
day or night or wherever you are. See you guys.
See you.